Let's jump into chapter 5.2 and look at the classification of igneous rocks. So by the end of this section, you should be able to explain the difference between intrusive and extrusive rock. You should be able to classify rocks based on felsic versus mafic, and then also based on the four main classifications of igneous rocks, being basaltic, granitic, intermediate, and ultrabasic. You should also be able to identify different textures, such as coarse grain, fine grain, glassy, porphyritic, and vesicular, as well as explain how veins, pegmatites, and kimberlites form. So if we look at these igneous rocks, they're either intrusive or extrusive. So intrusive means that it cooled from magma and crystallized within Earth's surface, and this usually leads to a coarse grain because those crystals have a longer time to develop, so they're going to be much bigger. Whereas an extrusive igneous rock is where it cools from lava and this crystallizes on Earth's surface and is usually a fine grain. It's going to cool a lot quicker. So if you take a look at the picture, extrusive would usually be something above ground, whereas intrusive is something that forms inside the Earth. So think of extrusive as exit. That molten material has exited the surface, and intrusive is still forming in the Earth. So these igneous rocks are classified based on four major groups. So these groups are based on the amount of silica content in them. So essentially, the more silica there is, the lighter it's going to be in color. So if we look at our first grouping, basaltic rocks, these are called mafic rocks, and these are usually a lot darker in color, and they have a lot lower silica content. So they're darker because they have less silica. And they're often very basic if we think of acids versus bases. One thing to think about, these are more dense and these make up the oceanic crust, and this will play more of a role when we talk about plate tectonics. But basaltic rocks usually have 45 to 53% silica within them. The granitic rocks, on the other hand, are the felsic rocks, and these are going to be much more light colored, and these are going to be high in silica and are going to be more acidic. These types of rocks commonly make up continental crust, so essentially the land that we live on, and this is less dense. And again, that'll play a role more when we talk about plate tectonics. With granitic or felsic rocks, you're going to have over 63% silica. And then we have an intermediate range that exists between this felsic and mafic, and this is usually going to be the 52 to 63%, and you can see it falls right in here. So you have granitic or felsic, which is light in color, your intermediate, and then it goes to basaltic, and this is where it gets much darker, and then you go to ultra basic or ultramafic, and these are going to be very low in silica, and usually below 45%, and as a result, that leads to a very dark colored rock. So if you take a look, this table kind of brings it all together, your four main classifications of igneous rocks, and then these form from the different types of magma that we learned in the last section, rhyolite, andesite, and basalt. And then you can even see the increasing silica content. You can see as you go from felsic to ultrabasic, the amount of silica decreases, and then also as a result, the rocks are going to become increasingly darker in color. And then also you have the temperature that the crystallization occurs, and this crystallization for rocks that have less silica usually happen at a higher temperature. Now we can think about texture. So texture refers to the size, shape, and essentially pattern of the grains of the rock. So there's a couple different types of textures. Three of the most common are coarse grain, and this is where you can noticeably see the different grains. Fine grain, where you can kind of tell that there are grains there, but it's tough to tell them apart. And then glassy, which is where it forms so quickly and cools so rapidly that these crystals don't actually have a chance to develop. So we could take a look. Coarse grain, you can physically see the difference between the grains. Fine grain, you can tell that it has different grains, but again, it's a lot harder and they're a lot smaller, so it's harder to tell. And then glassy, it cools so quickly that you can't really tell the difference from one grain to the next. A couple other textures that you see. A porphyritic texture occurs when you have these really large crystals on a smaller crystal background, and this usually happens from an inconsistency in cooling. So for example, these minerals would crystallize quickly, the smaller ones, whereas the larger crystals took longer to develop. And this happens because they're different minerals and they cool at different temperatures. A vesicular texture pops up when this rock cools and you have a lot of gas bubbles getting trapped in it. And then as a result, as it cools and hardens, all of these pockets lead to where the gas bubbles were. And then you have veins, and these veins pop up in the rocks where you essentially have a crack in the rocks, and then water with minerals dissolved in it works its way into the cracks of the rocks, and then over time the minerals within it will crystallize, and it leaves behind essentially a mineral streak within the rock. You can also get this with fluid left over from magma. And then we have pegmatites, which are igneous rocks that are made of extremely large grain crystals. So these often exist within the veins, and these crystals grow extremely large, and they're often with valuable minerals. And then kimberlites, on the other hand, are very rare, and they're usually ultra basic or ultramafic, meaning they're very low in silica, and these are rocks that have valuable minerals in it like diamond, and these often form under very high pressures. And then, last but not least, if we think about how igneous rocks are used in the world around us and where we see them, they're often used in a lot of buildings and a lot of structures because they're stronger. They support more weight compared to the other two types of rocks, sedimentary and metamorphic. And then also you see granite a lot of times in households, used in countertops, used in floors, and it's very common because it's so durable. So from the section you should now know the difference between intrusive and extrusive. You should be able to classify rocks as felsic versus mafic. You should be able to explain basaltic, granitic, intermediate, and ultrabasic. And then you should be able to talk about those different types of textures, as well as explain how those veins, pegmatites, and kimberlites form. Until next time, have a good one.